Hello everyone, welcome to my channel Cogent Coder. Today we are going to see one more problem on the topic backtracking. So the problem number is 1415. The kth lexicographical string of all happy strings of length n. As you can see, related topics is backtracking and string. Okay, so let's read the question. A happy string is a string that consists only of letters of set A, B and C. So our string will contain only these letters. The second point is Si is not equal to Si plus 1 for all values of I from 1 to S length minus 1. So that means no two neighbors can be same. Okay, here are the examples: ABC, AC and B, and this long string is valid because no two letters are same. And there are some not valid strings also: AA, BAA, ABA, BBC. So you can see this is not allowed. Okay, so no two letters can be same. Given two integers n and k, consider a list of all happy strings of length n sorted in lexicographical order. Return the kth string of this list or return an empty string if there are less than k happy string of length n. So n will tell us the length of the string. That means here ABC the length is 3, here the length is 2, here the length is 1. Okay. So n will give us the length of the string and k will tell us the which string we have to provide in the output. Let's see the example. Here n is equal to 1 and k is equal to 3. So we have to provide third string of length 1. Okay, so this is my first string A, this is my second string B, and this is my third string C. So my output will be C. And if k is greater than the number of strings, as we can see in the example 2, k is 4 and n is 1, so all the strings are this A, B, C, but they have asked the fourth string which is not available, so we will return the empty string. Okay, in the third example also n is equal to 3, so string length is 3 and we have to provide the ninth string. Okay, so this is the first, second, third, fourth, fifth, sixth, seventh, eighth and ninth. So this is my ninth string, so we have to provide this string in the output. But the main question is how to generate this type of strings. As we know n is equal to 3, that's why we are generating the string of length 3. So we got the first condition: whenever we reach the string of length n, we will push that string into our vector. Okay, let's assume we have only 3 elements. Okay, A, B and C. So if I start with A, I am using capital letters for simplicity. If I start with A, for second position I have options again from A, B, C, but I cannot take A because it is not allowed. If I take B, yes, it is allowed. Now I will check for the third position. Can it be A? Yes, it can be A. Now I got the string of length 3, so I will push this string into my vector. I will pop back the last element and I will check for the next element. So can it be B? No, it cannot be B. So I will check the next element, which is C. Yes, ABC is allowed, so I will push this string also in our vector. Now all the elements are over, so I will check for the second position. If any elements are remaining, yes, the last element was B, so C is remaining. If I take C, again I will check, start with ABC. ACA, yes, it is allowed. ACB, yes, it is also allowed. ACC, it is not allowed. Okay, I have covered all the elements for the third position also and for the second position also. Now for the first position I will start with B. Again the same procedure will go on. Okay, BA, A is not allowed, B is allowed, BA, C is allowed. okay, like this. Let's see this logic using diagrams and pseudocode for this problem. For the explanation, I have taken third example where n is equal to 3 and k is equal to 9, okay, and this is my pseudocode. So what this pseudocode tells us, if string size is equal to n, that's what I told you, if it is equal to n, we will add the string to our vector. If it is not equal to n, it will go into else condition and it will start a for loop, okay. So there is a for loop for all a, b, c, okay, for all the elements in this vector, and if it will check if the I is equal to the last alphabet. If it is not equal, then only it will run these following commands, otherwise it will check for the next element. So if the condition is satisfied, that means if I is not equal to the last alphabet, then it will add the I to our string and it will call the solve function again till the string size becomes n. After coming back from this call function, it will pop the I from string and it will again check for the next element in the for loop. Let's see this in diagram. Let's assume now the string is empty initially. I will call the solve function and it will not satisfy this if condition, so it will go in else condition and it will start a for loop. So the for loop will start with a, so that's why I have written here a. So it will check if the current letter is equal to the last alphabet of the string. So now my current letter is a. Here I will represent the current alphabet, okay, for this for loop. So my current alphabet was a and last alphabet was nothing because the string was empty. So it will go inside this if condition and it will add this current letter to my string. So I have added this alphabet into my string. So my current string is a, and it will call the solve function again. When it goes again, it will fail this condition and it will go in else condition and it will again start with the for loop starting with a, but for the a alphabet the condition will not be true because the last alphabet was also a and the current alphabet is also a. So it will check for the next alphabet, which is b. So my current alphabet is now b. Here you can see I have taken b now and it will satisfy this condition and it will go inside this if condition and add this current letter to my string. So my current letter was b, so it is now added to my string a. So now my current string becomes ab. Again it will call the same function and it will start checking with a. So the last element was b, so for a there is no problem, it will add to my string. Now the string becomes aba, and when it call again the solve function, it will satisfy this if condition in the starting. The length will become 3 and it will add this string to my vector, okay. So my first string will be aba, and now it will check for b, but for b the condition will fail and it will check for the next element. So the next element is c, and after checking with c there is no problem and we have got another string abc of length 3. So we will add this string also to our vector. Now there is no next element for this loop, so it will go back in the second position and it will check if there was any element remaining for the second position. So yes, there was c. So now it will check for c for the second element. Now the string has ac and it will again go with the same logic. After completing c, it will cover all the elements for second position. Now we have covered only a for the first position, so it will check for the next element, which is b, and it will again start the same logic, and for c also it will go with the same logic. So this is how the pseudocode will work. I hope you understood this logic using this diagram. Now I am going to write the code, but you can try by yourself by pausing this video, and still if you are not able to write the code, you can see my code. Let's go to the question again. Let's start with the initialization. So I am going to initialize a string str and vector string which will store all the valid strings, and we will make a vector for the elements provided in the question. I am giving the name v and the elements are a, b and c. So we are going to use only these 3 elements. Okay, now we will just call the solve function. Okay, and I am going to provide n, so it will check the length of the string. I am writing the solve function in this int n. So my first condition was, if the string length, if the string size is equal to n, then all string push back the string. Okay, so I am going to push back the string to my all string vector. Else, if it is not true, else we are going to run a for loop int I is equal to 0 to less than v size. Okay, and in this for loop we will check the condition if vi is not equal to the string last element. So this is the function which we are going to use, str.back. So it will provide me the last element of the string, and we are going to check the last element with our current element which is vi. So if it is not equal, then only it will push back the element into our string, and it will call the function again with the same parameter n. After coming back, it will pop the element to check for the remaining elements in the for loop. That's why we are popping each time. So this is my code, but it is not complete. Can you tell me why? Because we have not used the parameter k. What this k represents? This k will tell me which string we have to provide in the output. Okay, that means the kth string. Before that, there was also one more condition where k is greater than the number of strings available. So if the k is 4 in the second example, if the k is 4 and the number of strings are 3, then we are going to provide empty string. Now I am writing the condition. So if all string dot size, okay, is greater than or equal to k, if it is greater than or equal to k, I am using ternary operator. If it is greater than or equal to k, then we are going to provide all string k minus 1. Why we are writing k minus 1? Because in computer science the numbers start with 0. Okay, so k minus 1 will give kth string, and if it is not greater than or equal to k, that means k is greater, we are just simply going to return empty string. So this is my complete code. Now let's see if it runs properly. Yes, it is accepted. Let's submit it. Yes, we can see it is submitted successfully. So this was the complete solution for the problem. I hope you like the video. Please hit like if you enjoy the video and my explanation, and comment below if you have any doubt for this question. Also check the description below if you want to solve similar question on backtracking or any other topic I have explained before. I will be back with the new question. Till then, goodbye and keep coding. Thank you.